Hey everyone, I'm Jolly from Campervan Ventures, and today I'm going to show you how to install this beast. It's the Renogy Inverter Charger. If this is your first time here, welcome. If not, thanks for coming back. And we've actually got a video on the Renogy Inverter Charger, the unboxing, so it goes through all the components, what it is, what it does, and just a bit of detail on what the crack is with it basically. So I'm not going to go too much detail into that now. So if you do want to find out a bit more about it before you jump here, I'm going to leave a card up somewhere here to jump to that. But if not, here we are, and I'm going to reinstall the inverter charger. It's already installed obviously, and it's working and everything. We wanted to do that before a video, so at least, you know, actually kind of know what I'm talking about when I actually feed you the information. That's one thing to be wary of, obviously online. There's a lot of sort of false information, recommendations and things like that, which is fine. Everyone's here to help each other. But as an electrician, obviously I've been an electrical engineer for about 17 years. Try and get good sources of information. Obviously electrics is very dangerous. It can be dangerous. Work safely, and it's as safe as anything. Don't be afraid. Make sure you abide by the electrical regulations. That's the first one. And yeah, just get decent information. Hopefully this video is full of good information for you. I'll cover a few regulation stuff. I'm not going to go into in depth and bore you to death, but it's purely just based on this inverter here. This is going to be like sort of two-part video. So in part 2 I'll show you the actual electrics side of it, like the electrical consumer unit in regards to like RCD protection, that kind of thing. The reason I'm not doing it in this video is because I've only got a temporary board at the moment, temporary fuse board. It doesn't meet current regs, which is why I'm not going to show you. There's no point at the moment. So don't be horrified when you see a picture of it and think that's not to regulations. I know it's in temporary just to get it running and working, to make sure everything's okay, to be honest, and we're just waiting on the parts for it as well. So let's change the camera angle and I'll show you what the crack is with installing this in our van. So here it is, all 22.5 kilograms of it, so it's very heavy. If you haven't already got your Renogy Inverter Charger, when you do get it and get it out of the box, it's still a shock, even though you know the weight of it and the size. It's, yeah, we were quite surprised. We've actually got an unboxing video of this charger, so have a look at that if you want to have a look more in depth of the components and stuff inside here, which I'll take that cover off in a sec and show you. But I'm not going to go in depth with those in this video because obviously it's in the other video. So if you do want to look at those, I'll put the card up the top here somewhere just so you can click on and have a look at that, because I go into the measurements and stuff on that video as well. But just show you where we've got it installed. So just excuse the mess of the van, we're having a bit of a tidy today, which is why I'm doing this video. So that's the front of our van. So the cab is behind this wall here. Just to note, if your first time here and you don't know what van we've got, it's a Luton van. It's a Luton transit van. So that's the big bit above the cab, which is our bed. That's obviously the cab behind that wall there. So this is the front of the van. So our battery is there, and the obviously inverter charger's there, so we're keeping the weight as far forward as we can for better weight distribution. The further back it is, the more unstable the van's going to be with the weight. So yeah, we've kept it as much this way. So we've got a bench seat here, and it's all underneath the front of that bench seat, which fits quite snugly, to be fair. So we did bear that in mind when we were installing and making the size of this seat. We did bear that in mind, and there was plenty of room for it, and as you can see, it's got space. But with mounting it in the manual, it should never be mounted vertically on a vertical surface, since it would present a hazard for the fan opening, which is crucial for cooling the inverter. So all that means is the unit can be mounted, as you can see here obviously, or the base, it can be mounted on a wall like that. It can't be mounted upright, so obviously that fan either facing up or down, because of ventilation issues apparently. I can't see why that would be an issue personally, but that's what it's asking. I have noticed people mounting it that way, probably for space and stuff like that, so I don't know how they've got on, but obviously the geeks who wrote the manual have asked for that, so it's probably best. Right, I'm just going to do a few measurements just to show you the size of the compartment we've got our inverter charger in. Now obviously the actual size of this I'll put in a link in the description below of the manual, so that'll tell you the size. But obviously you need space for, you know, ventilation and cables. So obviously cables, you can see how much space they take up. There's a little bit of space in them. I need to put a clip in there actually. But it'll just give you an idea of how much space we've got. So just bear with me, I'm just one-handed. So our unit is about 600 mil. You can see there. From the wall it's about 600, and then width wise we've probably got about 300 mil, so you can't see it there. So from that wall there to the start of the cables here where they bend is about 600 mil, and then 300 mil across, so it's probably a little bit more over to this way where the box comes up to, just to create a bit of airflow. So 600 would be 300. Now this unit does get quite warm. Obviously if it's a hot day outside it's going to get warm. It's not so much hot to touch sort of thing. Obviously this heated up from what heated the actual room itself, but there is a temperature gauge on here, and it can get quite warm, so the fan does kick in. Now the fan is actually there, look. It's behind this unit, which, like I said, I'll take this off in a bit and I'll show you what's inside. But the fan's in there and it pushes air this way if you do need to know. So the air is pushed that way. So you can see there's like holes here and there's holes that side. There's no fans in there, it's purely to draw the air through the unit. So you need to make sure there's nothing either side of it, which you can see we've got gaps. There's all gaps there. There's a big gap here which we've left free purposely for that fan, just to give a bit of air room. We've got a dropout vent there which comes out, sorry, it comes out here, which I've just shoved the table in there for now. What else we got? We got a vent there and a vent there, and we've just put Hessian on rather than a ugly dropout vent, just to make it look pretty. And then the other thing we've got a dropout vent there, as you can see, under the storage. So we have a box which is there, which fits into this area here, which is quite nice. So it fits there. So we've got no like duvets, towels or anything against this, which is going to block that vent. There's still airflow at the back. So like a dropout vent there, and there's also a dropout vent underneath our solar charger, because that needs airflow because it gets warm. So we've got a dropout vent under there. So at least there's a bit of airflow, and it does create airflow under there, surprisingly. It keeps it quite cool actually. We've got all sorts of stuff under here, and it's there's bottles and liquids in there, and they actually stay quite cool even on the hottest of days, which is nice. Also the manual does say to keep it away from EMI, so that's electromagnetic interference, or anything like TVs, radios, like visual electronic, anything like that. It could interfere with the electronics of this, which we haven't got anything in there at all. Like I say, we've got all our electrics are in here, the solar charger, the fuse board, anything like that, and it's working fine. There's no interference or bother. The other thing it asks as well is not to have gas in there, that's kind of a given with electrics really, because and electronics, if there's ever, you know, a spark, anything like that, or an issue, you could have further issues obviously if there's a gas leak or anything. So just keep gas out of here. And the next point is fixings. So the unit comes with sort of legs, feet, and we've just put some screws in, literally just to hold it down. There's two here and two the other side, two down there, and it doesn't move. To be honest, I don't think it would move because it's so heavy, but obviously in a van it's wobbling, and you know, there's a very high chance it could move, so make sure it's secured properly. We did contemplate putting it on a rubber mat, so at least it's really fixed, but we put the screws in, tried it, and it's gone nowhere, and they're still tight. So that is that. So the last note on location for it is it needs to be close to the battery. It's purely for reducing voltage drop. So the terminals for our battery are here, just under there, and the terminals in the inverter are through there. Now if you hear me talk about voltage drop and wonder what the hell I'm going on about, voltage drop is basically the voltage that's lost throughout a cable. So for instance, if this supplies 12 volts, just example, exactly 12 volts, you want 12 volts at the battery. If the cable is short, you're going to get 12 volts. If the cable is very long, for example 100 meters, it may lose voltage, so you may only get, say, 11 volts at the battery, which is going to obviously less efficient. The ways to overcome that is either shorten the cable or make the cable bigger. Now by making the cable bigger in a van, you've got an issue of weight because cable is very heavy, and it's the issue of the terminal sizes. So there's only, like for example this isolator, you can't have the biggest cable possible in here because they won't make the lugs big enough to connect it. So you need a cable size that will obviously fit in here. And the other thing is price. Now the bigger the cable, the more expensive, and this cable is very expensive when you start getting to big sizes, which I will go into in a bit. So that's a quick note on voltage drop. Just keep it as close as you possibly can and you won't need to worry. Now to get into the electrical side, you've got a panel here which just like little posi screws really. There's two there, and there's also two, I've actually lost that one, but there's two there and two the other side as well. So there's two, four, there's actually six. So that bit comes off, and then this white bit here folds down, so I'm just going to do that now. So here we are then. So that's with the top bit removed, and I've just pulled this forward a little bit. We don't need it all the way off. It's just to show you what's inside. So obviously down there you can see the neutral battery terminal. There's the positive one just lurking down there. Now these ones here, if you've seen our other video, we go into all these components and everything in here, but you'll need an M8 nut on those terminals. Now it doesn't say that anywhere in the manuals or anything for this, and that's useful not only so you can have the right tools, but you can see there we've got a lug on that, on the battery terminals. Now the cable's 35mm, so we've got 35 by 8mm lugs, which means it's 35mm cable and 8mm hole. So that's that. There's a grounding point there. I don't actually know the size of that, but I'll write it. You'll see it pop up here because I'll do that at the end, and I'll let you know what size that is. That's for the grounding cable. And then these two here are the 230 volt cables. So you've got your input, which is these three, and your output, which is those three. And the last one is this one here. So this is your remote. So this is plugged into the RJ11 socket, and literally all it does is just pushing. It's like an internet computer cable, just plugs in. So this controller, if you're wondering where to mount it or anything like that, the cable's 5 meters long, which is 16.5 feet or something like that. Now we've got it mounted, so we've routed our cable through the cupboard, through that cupboard there. It sort of goes up underneath here, all the way around, and it's up here. So this is where all the magic happens, up here. So there's the controller. There it is. Now all the controller does is turn the inverter charger on or off. That's purely all it does. But in regards to use, I would recommend fitting this somewhere you can get to it. So which is why it's above our door, right by the bed, so we can make sure it's off on a night or on a night or whatever. And what you've got is, sorry, the camera's a bit struggling with the light today. So you've got an on and an error. So on, when it's green light on like that, it means you've got 230 volts. So it's on hookup basically, or shore power, however you want to say it. When it's flashing, it means it's running on the inverter. So you've got no hookup, but the inverter's supplying power to all your 230 volt stuff. And the error, that's a red light that will just flash when there's an issue. And all you do is just press that button, simple as. In fact, what I'll do, I'll show you. So if I turn it off, so it's on hookup, but if I turn that off, it'll actually switch off the inverter charger, so it turns it off completely. So we're not charging and we're not doing anything. We're actually fully charging. See here, we're 100% fully charged at the minute, so it won't charge anyway. So what I'll do now, I'll just switch the power off and then turn it back on and show you it on the inverter. And then this is what happens. So this just tells you it's on the inverter. This can be a little bit annoying on a night if you are bothered obviously by lights and stuff. It might seem like a tiny little green LED, but when it's pitch black, this lights up the room quite a lot. So that may obviously affect where you put it. It's right by our bed. I mean, we do sleep up here. It looks a bit of a mess. It's not a bed at the minute. Our head's there. We're fine with it now. We're quite heavy sleepers, so it doesn't bother us, but that can light the room up, so be aware of that. Right, DC wiring. Now the DC wiring is all the battery wiring. So what we have here is a battery terminal. So there's the negative and just under there is the positive. Sorry, it's a bit tight and cramped to show you. So these are M8s. So they're M8 nuts and M8 holes. So when you're buying your lugs, obviously your lug size needs to be the size of the cable. In our case, it's 35mm. So the lug will be 35 by 8mm. So just a point if you are buying, if you need lugs. So they're literally just the other side of there. So you can see with the negative, it just comes up and it goes onto our negative buzz bar. I'll just remove the caps for these now just to make it easier for showing you. So we've got a negative buzz bar here. We've got one negative that goes onto the chassis and then supplies all of our negatives. That just makes it easier for maintenance or any other issues. We can all just get to this. If you do put a lot of negatives on one bolt on the chassis, it means you've got to undo all of those to get one out, sort of thing. In this case, if we have an issue with one of these, we can just take one off and then leave the rest of them on, which makes it a bit easier. Now the positive obviously runs through there. I'll just show you what happens with that. It comes up and it goes into an isolator. So now this is a 300 amp isolator, because then we have a mega fuse. If I can get into it, there is our mega fuse. Just zoom in, there we go. So we've got 200 amp mega fuse, and then from there it goes straight through onto our battery terminal. So you can see there, straight on the battery terminal. So it's very short, which means obviously we can keep the cable size down and reduces voltage drop. The reason we've gone tri-rated is just because it's like fire retardant, so it's generally used in like panel building and inside metal cabinets and units and stuff. It's just better cable. It's a bit more expensive, but we would recommend using tri-rated. The next cables are the AC cables, which are these ones here. So we've got input and output. Now your input is what's obviously supplying the inverter charger, which is our hookup. Now I'll just show you the consumer unit. So like I said before, please don't hate me or rip me apart for using one that doesn't conform to regs at the minute. It literally was a temporary board because I'm an electrician. I literally had this board lying around, so I've just thrown it in. So what we've got is, just to show you, our hookup comes in to an RCD, and then it goes out through that breaker then to supply this. So that's what that cable's doing there. So currently it's turned off, so you can see there the input is 0, output's on because it's running on the inverter. The output AC cable, this one, goes round, and you can see that it's routed, and it kind of goes around the back of here, and it goes into our consumer unit. So it comes in the top. Now at the moment, all it's doing is going in, and it's actually linking onto the buzz bar for these circuits here. So these two are for the inverter, and these are the outgoing circuits, so like our sockets and things like that. At the moment, that's what it's doing. What it will do in the new fuse board is it will come in to a breaker, which we'll use purely as an isolation switch. So if we need to work on these circuits, we can just turn the breaker off if need be. But what we'll do, obviously, in part 2 of this video, we'll do an overview of our up to regulations consumer unit. Now the input and output cables here, they are flex, which is the cables you should be using
when doing the vans. You shouldn't be using solid core cable because obviously with the vibrations it can come loose. Now with flex cable, it's stranded, so the cores are stranded. So I highly recommend you install these. These are called Ferrules. So basically you just put it on the stranded bit. I don't know if you can see the strands in there actually. You might be able to just see the strands. You can just see the strands in there. So this ferrule just sits on the cable and it comes with a crimper, and you just crimp it on basically. So what that does, it just means that when you put it into the terminal, it's a much better connection than trying to squash all the basically stranded cores down. So that just then goes into there. If I can get it in, there you go. And then tighten it up, job done. Because otherwise you've got to, you know, make sure you twist it all, and sometimes the not all the strands get actually crimped by the screw. So I'll put a link to those below.
Now the 230 volt cable, this is 6mm, so it's 6mm flex. We've actually used Arctic external cable. The reason being is because we had the 6mm Arctic left over. We used it for something else in the van which runs outside the van, which is why it's Arctic cable. So we've just used that. Doing our cable calculations, we could have got away with 4mm and it would have been fine. The reason we've gone for 6mm, one, because we'd already got some left over, and it's what's recommended in the manual again. Now I have written it here. I actually spoke to Renogy to ask this question because this is the manual we were sent with the unit, but the manual online you download actually gives you this recommendation, which we didn't have. So I thought I'd ask the question. So it does recommend 6 to 16mm, which is 6 to 10 gauge cable. So we just put 6mm in, and it's more than enough for what we need. You can go what the manual says, which is fine, but I highly recommend you doing your own cable calculations and things like that, just to make sure you've got the right size cable. Now with any cable calcs with electrics, what you should do ideally is design the cable for the maximum output of equipment or anything. For example, this is a 2000 watt inverter. There's a 2000 or a 3000. Now in the manual, here we are again, we've got the 2000 watt model, recommended fuse size. Now recommended cable size is 2/0 gauge. Now that gauge cable is 70mm. Now that's a beast. Now you can see obviously this is 30, that's 35mm, that's decent. That's 70mm. If you go with the 3000 watt, it's asking for 120mm cable. So what we've done, the reason we haven't got 70mm cable, because obviously the cost and the effort of fitting it in here would have been an absolute nightmare. We've done some cable calculations and designed our electrical system so we know how much power we're using. Now if obviously you're building a van to sell on and things like that, you need to make sure obviously the cable's going to be big enough. You don't know what they're plugging in, so you'll need to fit the cables recommended. However, we aren't. We live in our van, we know how to use it, we know what to use on it, what plugging in. So we've designed our install on 1500 watts. Basically, if everything's plugged in, everything's working at full capacity, we will pull about 1500 watts. And that's never going to happen because we're never going to be charging all of our things. The fridge isn't going to be at full whack, and our blender and we've got a mixer and stuff for cooking, they're never going to be on full whack. So we've calculated to pull, it'll pull 700 watts max. So the amount of stuff we'll use at once will be about 700 watts, which is, this cable's going to cope with that absolutely fine. No problem at all. So obviously there's peace of mind through that one, and obviously with these cables here, we know it's never going to pull more than that. So that's just something to bear in mind with cable sizes. You can fit any cable you want, as long as obviously it's going to carry the amps and it's going to be safe. Which brings me on to my next point of fusing and cable protection. So any cable that's carrying obviously power and current needs to be protected by a fuse or like a circuit breaker. The reason for that is all cables have got a max rated current carrying capacity. So you don't want it to go, the current to go over that, because that's when the cable's going to start burning out and causing fires. So these are here to protect it. So what happens is the hookup outside comes in to our RCD. Now the RCD is fed from an AC 230 volt power supply coming in from like your house or hookup. Now this RCD is here to protect you as a human. And what will happen is if you have a shock, so if you're touching a cable, this is going to sense an imbalance and trip out. I'm going to go a bit more in depth into how an RCD works in the next section, but put it plainly, this is a 30 milliamp RCD, and it's 30 milliamp 63 amp RCD. So then from the RCD, it goes into a miniature circuit breaker, an MCB, which then goes out there, goes around, and is our input for our inverter charger. So at the moment, our MCB is rated at 20 amps. Like I explained before, this is like a temporary board. So I had a 20 amp in here. So 20 amps there now. I'm also testing it on 20 amp because we charge at about 40 amps, 30 to 40 amps. So I'm actually just testing it to see if this breaker will actually hold, which it has done so far. So it's been okay. So I'll probably leave it at 20 amps. Now, the size of breaker needs to be less than the maximum current carrying capacity of the cable. So, for example, if your cable can only carry 40 amps max, this needs to be less than that. The reason for that is you need this to trip out before the cable burns out, basically. So it's a race sort of thing. You need this to trip out before the cable burns out. If all this technical jargon's confusing you, like current carrying capacities, amp ratings and all that sort of stuff, don't worry, I'll explain it all in very simple terms in a blog post. So it'll help you to choose the correct size MCB, RCD and cable as well. And it'll also tell you the current carrying capacities of the cable so you can get all your components to work and fit safely. Now our issue, or my issue, which I've raised with Renogy, was this cable's not protected here. So obviously from there to there, there's no protection, which is, I know it's only short, but obviously if there is a problem with this cable, don't know how it's protected, which I asked what sort of fuses there were, internal fuses, and there are two fuses. They're actually underneath that green switch there. They're like self-reset fuses. Actually, hang on, I'll show you. There they are, look. There they are. These two here. Yes, the self-resetting magnetic fuse is rated at 20 amps apparently. Those two there. Now, the biggest question we get asked in regards to this inverter charger is, do I need an RCD? So the answer to that is both yes and no. So on the incoming side, which I've just explained, but for the purposes of someone jumping to this section, I'm going to explain again. So the incoming side, yes, you need 100% need an RCD. The outgoing side, so obviously the incoming side there, the outgoing cable, no, you don't need an RCD, and the reason being is that it just won't work. It won't work on this unit. Now the reason it won't work is because this unit is a centre tapped inverter. So you've got centre tapped or bonded, two different ones. Now when people talk about these and say, oh, it's like house power, yes it is in a sense, except when it's centre tapped. So what the hell does centre tapped mean? What it means is there's no neutral to earth reference. So what that means is it's floating. So with the incoming cable, sorry, I'll show you here. With your incoming cable, you've obviously got your live, your neutral, and your earth. So what you'll get is your live to your neutral will be 230 volts. Your live to your earth will be 230, whereas your live to your neutral will be 0 volts. Now the outgoing side, your live and neutral will be 230 volts, but your live to earth will typically be half of that, so it might be 115. And your neutral to earth will also be 115. So whereas your incoming side you've got live, neutral, earth, so then your outgoing side you've got line 1 and line 2, and they're not actually connected to an earth at all. So why won't an RCD work? So this unit here will sense an imbalance. So what will happen is the power going out of the live, it's going to expect to see coming back in on the neutral. So under normal circumstances, no faults. So the power goes out the live and back in on the neutral. Absolutely fine. It's going to work. A scenario of, let's say this live is touching this casing here. Obviously the casing's metal. I'm touching the casing, which means the live's going to come out of the RCD, into here, to the casing, through my body and down to earth, and give me a lovely little tickle on the way through. So what will happen then is the power going back through the neutral is going to be imbalanced. So it's going to, the fault path will be through the live, through my body, down to earth, and it's going to change what's coming back through the neutral. So the RCD is not going to be too happy with this, and it's going to just trip out. It's literally, it won't trip now because I've got no power onto it, but it'll trip out because it will sense the imbalance, which is why this is to protect you. And the imbalance is set to 30 milliamps. Now the reason it's set to 30 milliamps is because obviously doing lots of different testing to design these things, that's sort of the limit before you die. Sorry, the fan's just kicked in if you want to know how loud the fan is. There we go. So yeah, it's set to, it must be set to 30 milliamps for obviously these purposes in a van. So the reason we must have one on the incoming side, obviously the power coming in from outside, is because the neutral to earth is bonded. So if there is a fault or you touch a live cable or anything like that, it will create a fault path and an imbalance and then trip this RCD out here. You can do tests on an RCD, which I will do in part 2 once I've got the new fuse board and everything in. I actually have my tester and I'll do some tests to show you what actually happens when theoretically putting a fault onto an RCD. So to answer the question, do I need an RCD? It's yes and no, but it's no on the outgoing of a centre tapped inverter. Now with choosing between centre tapped and bonded, it's quite hard. When you're buying an inverter, it's not there in flashy writing or anything like that on websites. You really don't know. I'll be perfectly honest, I didn't know this was centre tapped when I bought it. I bought it for all the other reasons, and then with installing it and playing around and stuff, then I actually realised it was centre tapped. If you don't know it's centre tapped, obviously before you buy it, you can find out, ask the manufacturer and things like that, or online. If you bought it and you don't know if it's centre tapped or not, do a test. So if you've got a multimeter, test like you would on the incoming side, test like live to neutral, live to earth and neutral to earth, and it will give you readings that will show it's centre tapped. In fact, I'll put the readings somewhere up on this video just to give you readings that you should be looking for. Now if you've got a bonded inverter, that's a bit of a bonus, and I think typically bonded inverters are quite a bit more expensive. They seem to be like different manufacturers do bonded ones. Top of my head, I'm not actually sure which ones do, but a bonded inverter acts exactly like your hookup will coming in. So with a bonded inverter, you will need an RCD on the outgoing. So as well as, sorry, camera's a bit mad. So as well as an incoming, we pretend this is bonded, so you'll have an incoming RCD. On the outgoing cable, you'll have another RCD here, then going out to protect the other cables there. So the next big topic of conversation is grounding. This seems to be a bit of a confusing topic, so I'll do my best to explain what's going on here. So in the manual it recommends it. It recommends that this is bonded to the chassis. So when it's saying it's bonded or grounded, what you're actually grounding is like the metalwork and the chassis and stuff on here. Obviously talking about centre tap before, there's no earth reference, so what we're actually bonding is the metal stuff. So you can see it, hang on, I'll get my hand and fingers in, there it is there. So that's the bond, and it's a 7mm socket bit to the nut size, sorry, is a 7mm for that, and it's an 8 gauge wire, which is what the manual recommends. So we've put an 8 gauge wire in, and what that does is it comes around here and it goes up onto the neutral buzz bar. Now it goes the exact same path as the DC neutral one, so we've actually been asked before, can you not just link that to there? Yes, in theory, but you shouldn't do it, because this cable here, which is your DC, that's obviously designed for the specific current to be carried, so it's a 35mm. If you're adding this, which is requested to be 8 gauge, you should then be uprating the gauge of this, if that makes sense. So to link that one to that one, you need to be, in our case, we've got 35mm plus 8 gauge, which on top of my head I can't think what it is, but I'll put a note here. So you need to double it to ensure it carries that current. So what we've got is it comes up to the neutral buzz bar, and then the neutral buzz bar, we've got a big cable which then goes down underneath here to the chassis. So it's all bonded fine and dandy. Why does it need bonding? Now, the reason for bonding this really is purely for the RCD. It's to create a fault path for the RCD. Now, previously I was explaining RCDs, obviously, remove that, being centre tapped, the outgoing doesn't need an RCD, whereas the incoming does. So what could happen is the live could come out or be cut into or anything and actually touch this casing. Now, I would imagine it's bonded within the unit, but it does ask for an external bond, so maybe it isn't. So what will happen is the live will touch this casing. If this is not bonded or touching any kind of earth or other cable or anything, this will just stay live. So hopefully the RCD should trip because it will sense an imbalance, but if it doesn't, this will just stay live. So what will happen is the power will come down the live, touch the metal case, go onto our grounding point, which is called earth or bond. It will come up to here. It will then go down from there to the chassis, and then what we've actually got an earth from here down to the chassis as well. So what we've created like a fault path back to the fuse board. Now what will happen with that, obviously it's with its fault path, the RCD should sense an imbalance then if this ever becomes live or there's a fault inside or anything. So then it should sense the imbalance and trip out. So that's the reason why this unit needs bonding. And also, just mentioning with RCDs, obviously with tripping out and stuff, it will actually work the same with the MCB. So if a live or anything does touch this, and because this is bonded, this is, you know, got the earth path to it, then it will pop, it will blow, and it should blow that fuse there as well, which is another bonus for grounding. And again, on the blog post, I'm going to put a detailed diagram of how we've grounded it, and just a few hints and tips on grounding and a bit of an explanation. So if it did get a bit confusing in the video, head to the blog post and it'll all be explained there as well. The only other thing to cover really in this part is that's for temperature sensor, which we don't need because we have a lithium battery, so we don't need a temperature sensor. So this is your display then. So this is just an LCD screen, and then you've got AC stroke inverter charger and then fault. So it's currently on the inverter, so you can see there's no input but there's an output. If I just switch on the input, which is the hookup, it's on, and now we have a solid light, so it's basically saying AC is on. This CHG, that's charged, so when it's actually charging the battery, it's not charged at the moment because the battery is 100%, which is nice. So that will flash when it's charging, and obviously if there's a fault, that flashes red. In the manual it does show you, so under operation it does tell you how to go through the settings. It's very simple. So what you need to do is press and hold this, and this is where this annoying noise comes from. Isn't that pleasant? This takes you on to basically settings list, so if you go up and down, it goes between different ones. That noise, apparently you can turn it off, but I've spoke to Renogy and basically said I've turned it off and it won't go off. And they just advised me to reset the unit, so turn it off, let it power down, turn it back on, do it again, and it keeps doing it. So maybe it's a faulty Bing thing or something, I don't know, but it is quite annoying. 1. So this setting's utility or battery priority. Now, utility priority is basically when you've got hookup, it will power your loads, so it will bypass the battery and it will also charge the battery. Now, if you set it to, so click that one, like enter, and then go up and down. If you set it to SBU, that's battery priority, it will only power your loads when the voltage drops to a certain level from the battery. Then it will power the loads and it won't charge your battery. So that's that one. And then 3 is UPS. We've got left that as default. So that's for like sensitive equipment like computers and stuff, which obviously we use and things like that. So we've left that as that. Power saving mode. Now we did set this, so basically it'll turn off until it senses 50 watts and it'll turn on. And what we were getting was, so SEN, that's mode enabled, so that's your power saving mode on. So it'll only come on when it senses 50 watts. Now the issue we were getting is we weren't using 50 watts, so we had no power. So in the end we just put it back on to SDS, so it's not on power saving mode, but we switch it on and off when we need it, so we ain't worried about that. 5 is, that's your battery. So in the manual it shows all the different battery types, so this is how whatever you want to set. Now it's got boost voltage and float. This will come from your battery manufacturer, so when you buy a battery, check the spec and it will tell you what it is. Alternatively, if you want lithium, it's this one here, BL, because these are all labelled on. Yeah, you've got gel, you've got sealed lead acid, open lead acid, things like that, and you can change these if you need to, but ours is lithium, so it's set to BL. It's missed 7, so our unit doesn't include this setting here. There's no option for it. And I did speak to Renogy again saying, why don't we have this? And they basically just said it's the unit we have. It just doesn't include that setting, so which doesn't really matter because we're not going to mess with it anyway. So this is your output frequency, what I was talking about before. So you've got 50 hertz or 60. So obviously just check the country you're in, but if that's, if it's, rather than stressing and worrying, just set it to 50. Default is 60, so that's one of the settings you want to change. Now 11 is your charging, so what charge power goes to your battery. We've got ours set to 40 amps. This unit goes up to 63 amps. We don't need that much power coming in, to be honest, so just have a bit of a slower charge. Obviously 63 amps will charge faster, but ours is set to 40. To be honest, if we've got a lot, quite a bit of time, we'd even drop it to like 20 amps. But the reason we set to 40 is because that's the output ampage. So obviously if we've got quite a bit of load on the battery at the time, we need to take that load off this figure, and that will give us the figure that the battery is charging at. For example, if the battery load is 10 amps and we're supplying 40, 30 amps is charging the battery, if that makes sense. So we've set, and that's easy to change. I think it's increments of 5, I think. Yeah, so you can change that. So you can play with that as you will. Okay, so option 12. Now, you can only set this if it's set to battery priority, which is option 1, I think it was. As is set to utility, so you can't alter that one. So next is... Oh, I did go in to try and set it, but it wouldn't set. 13, that's again, battery priority is required for that one. So if you've got battery priority, you can change that. But in our case, I'll show you. Can't do it, it's just a noise. So then 18, we have the alarm control behaviour. We've just left that to on. So this is basically just to turn the alarm on and off, but we've left it on obviously because it's an alarm. It'd be very annoying if it does go off, but obviously it's going off for a reason. So the next one is 19, which is, this is just screen mode. So what this means, we've changed this from default. So it just means that after 1 minute of inactivity, it stays on the screen that we left it at basically. So while you're setting up, you definitely want this on. Otherwise you've got to keep going through your settings to get back to it. So we've just changed this and just leave it as is, to be honest, just to stay on the same setting, because we can go back ourselves. So LCD screen mode. This is also, we've just set this to on while we do this like tutorial install video. Otherwise the screen will just keep going off, obviously to save power and things like that. So once we're done with you guys, we'll set this to off, and then it'll just go off after inactivity, so it's not wasting any juice. Just a point actually, while we're going through, all the information I'm telling you is in the manual, so you can just sit and read through it, but obviously I'm just covering what the settings we've got. Now this is the annoying one. This is number 22, which is the mode sound. Now it's set to off, but obviously as you can hear, it's not off. So hopefully yours turns off. The next one is 25. So that's to do with fault code, so we don't need to mess with that one. 26 is to set the boost voltage. So if you're setting this program here, you can change, like I said before, you can change the boost and float, and that's what setting 26 is. So 26 sets the boost and 27 sets the float. So if you've got that set on program 5, you can alter them there. So what will happen with 29, what will happen here is you can set, this is set to default 10. So when it drops to that voltage, it'll turn off basically because there's not enough. I mean, that basically means the battery's dead. So hopefully it'll never get to that point. So you can change that if you need to. Now 92, as you can see here, is not in our manual. And something else I pulled up, but that's to set the lower input voltage limit. So the lower input voltage we've got set to 200, which I believe is default. 92, actually, it's only effective if the UPS is selected in program 3, which is default, and we've got it selected. It's for like sensitive equipment, so you're going to have UPS set. But 92, the reason why it's not in the manual is because it's only available on the 230 volt versions, which is what this is. Now if you buy an American one, or other countries that don't use 230, so it's like 120 volts, then you won't have this 92 setting. So if you're from America, ignore 92. 93, this is to set the hertz option. So here the frequency range basically. So ours is set, so we want 50 to 60 hertz. So we've got ours set to GEN, which is 50 to 60. You can set it to 40 to 70, give you a bigger range, but you should only ever need 50 or 60. So that's what 93 is. 94 is to set the battery type. So that's if you're putting like a custom battery in. You can change the settings there. We're not, so we're not going to bother. 95, that's to do with the high voltage for the dry contacts, if you're using the contacts. I'm not going to go into the contacts with this because we haven't used them. I haven't had a chance to test, and it's likely you'll never use them, to be honest. But you can change the settings to turn the contacts on and off and stuff basically. 96 is to do with contacts, so we've not bothered with that. 97 is also contacts. 98 is a low battery voltage alarm. I think it was set to 10.5. Now 10.5, the battery is basically dead. Now we'd rather know the battery is nearly dead rather than it is dead. So we've set ours to 12 volts, which for our lithium battery would be about 9% charge. So at least we're going to get an alarm before it dies. I mean, I know 9% is very small, but we'll have about 20 amps of power left for emergency use or something. And then last but not least, is 99. So this is to set the output voltage. So on the home screen, so just go back, there's your output. So that's to set sort of the max output is 230. So if I go back in again, let's go the other way. You can go backwards as well, by the way, so you haven't got to go through. Yeah, so we've set ours to 230. But yeah, you can change that if you want, whatever you like. Goes up in, oh yeah, it goes up in tens. Obviously, if it's going up in tens, you want 230. Most appliances and the general UK voltage should be 230, and for appliances it's 230, between 220 and 230. So set that to that. So that's it, guys, pretty much. I'll put the manual in the description below, so obviously before you buy or install or whatever, you can get access to that. It's boring reading manuals, but to be honest, it's worth just read through it before you do anything, so at least you've, in the back of your mind, you kind of know what's going on. And it is good, it does the job. I have had to, like I've said throughout the video, I've had to ask a few questions from Renogy, and they've literally within a day, 2 days max, they've got back to me with answers, and they are really helpful. There are quite a lot of bad reviews. Everyone's fast to shout about the support with Renogy, but all our equipment's Renogy, pretty much, and any questions, they're more than happy to help. And I've fired them some really technical questions to the technical department, and they've got back to me and answered the questions, which is great. And also I've obviously got loads of notes and stuff in there, so everything that's sort of covered in this, like I said, I'm going to write a full detailed blog post of the install. So, you know, you've got the video so you can see what's going on, but you've also got, you have it in front of you to go through and stuff. And then all the materials and things like that, anything we've used, I'll put in the description with a link to, so you can look at those. Main thing with electrics, just be safe. Use your multimeter, just check, make sure everything's dead and stuff like that. If we can be any help at all, please comment or email us. Obviously we've installed, done it all, so if you do need help, please shout out, we'll help. If there's anything we've missed, leave us a comment. If there's anything we've done wrong or you don't like, or you want to rip my work apart, that's absolutely fine. Just leave me a comment and I will delete it. No, only joking. So we'll do a part 2. I haven't actually got my test equipment on me at the moment. When I get my test equipment, I'll do some tests. I'll try and test the internal fuses in there to make sure they work properly, and I'll do some RCD checks on the outgoing to make sure that's legit and we're all happy that we're all safe and whatever. So yeah, happy installing. Goodbye.